So let's do a problem together and make sure we have our calculators. I think I have my calculator. Here we go. My calculator. All right, so density. What do we know about density? It's mass over volume. Okay, and the type of property that density is it intensive or extensive? Intensive or extensive? Intensive or extensive? It should. Density is an intensive property. Intensive property. Okay, remember what intensive property means. Intensive property means that how much, how little, the density will remain the same. Okay, so if you have a lot of mercury or a tiny bit of mercury, this density will always be the same. Okay, it does not matter how much you have. So in this problem, we have the density of mercury is 13.6 grams per mil. Okay, mass in grams, volume in mils. Calculate the density of 5.50 mils of the liquid. So this is how we'll solve this problem. We have 5.50 mils of mercury and then 13.6 grams. So 13.6 grams per mil. This is how I want you guys to solve the problem. Mils and mils cancel, and then 5.5 times 13.6 is 74.8. 74.8 what? Are we just going to leave that number there? 74.8. Correct. Okay, so very good. I want you guys to put units. If you don't put units, the number by itself is meaningless. The minute you put units in, the number has meaning. Yes, Zachary? Okay, so units, units, units. Okay, so don't forget your units when you do any problem. Okay, on the quiz, on the test, I will mark off half a point if you don't put the units. And what are the units? Okay, it's going to be grams, not milligrams, not milliliters, not degrees C. Okay, units of mass are in grams. All right, let's talk about sig figs for a moment here. Okay, so why do we do significant figures? I'll tell you a story. I remember this. I don't remember many things from my life, but this one I do remember. I was in my PhD schooling or whatever, and I was presenting PowerPoint. PowerPoint was just starting back then. And in the presentation, I put all the digits. I figure my calculator has all these digits, so I put all the digits, every digit that was on my calculator screen. And then they were very upset, the committee and all of that. They said, all those numbers, that's trash. Like, what? I was taken aback. So this is why we do significant figures. Anybody here an engineering major? I think they should have some engineering. Oh, wow, a lot of you guys are engineering majors. Okay, so you're not going to report, all the digits. Okay, if you have a graphing calculator, Noah, okay, you're not going to report 100 digits on your answer. It gets to a point where it's just, they're right. Okay, the digits become meaningless. Okay, you only report what you can report. You need an adequate cutoff. So that's why we do sig figs. So remember, we're never going to report every digit on our calculator just because, we think, oh, I need to show the teacher that I did it, so I'm going to, put all these digits in from my calculator screen. So we need to know when to cut off, okay, the 10th place or the 100th place, how many decimals we need to report this as. Okay, so the cutoff for sig figs, significant figures, call it SF. And then also for sig figs, the issue is zeros. Okay, are they sig or not? So let's just go over some rules. Now, I'll be very explicit on the exam. Report it to 2 decimal places, report it to 3, significant figures. I'll tell you that. Okay, but these are rules that I want you to know, especially for the engineering friends. These rules will come handy to them. I know engineering, more of the hard sciences. You can't report every digit on your calculator just because. Okay, first of all, any digit that's non-zero is significant. Okay, so this is real, this is real, this is real, this is real. So this will have 4 sig figs. Okay, right? So if it's a real digit, it's automatically significant. Now the zeros are an issue. Okay, so this rule 2 tells us that if the 0 is between 2 real numbers. Okay, so this is a real number. 6 is a real number, yes. 0 is a question mark, is an issue, and then 6 is a real number. So if that 0 is between 2 real numbers, if it's flanked, surrounded by 2 real numbers, it's considered significant. So this will have 3 sig figs. All right, decimals. Okay, you're going to look for the first real number. Okay, 0 is question mark. 0 question mark. 8 is real. That's your first real number. So this will be 1 sig fig. It turns out that this 0 and this 0 are not significant. So that will be 1 sig fig. Now this is where the tricky part comes in. Okay. This is where the tricky part comes in. The tricky part comes in if I change this from 0.08 to 0.080. Okay, now what? Okay, liters. How many sig figs is it? Okay, this is real. It turns out this 0 is also real. It becomes real. Okay, so a 0 to the right of the first real number and a decimal. 0 to the right of the first real number in a decimal is significant. So how many does this have? Okay, this will have 2 sig figs. What if I do this one? How many significant figures is this? 4. Okay, how many is this? About that 0. Is it significant or not significant? 6 sig figs. You guys see that? 6 significant figures, 6 significant digits. Right, how about this one here? To the right of the decimal, this is real. Okay, so this would be 2 sig figs. Okay, what if I change this to a decimal? 0.20. How many sig figs? 2. What about 2.1? 2.01? 3. Okay. Okay, I want you to get these rules. So what is significant versus what is not? Okay. And then how about this one here? Real, 3 sig figs. Okay. Right, so we have some rules here for significant figures I'd like for you guys to know. On the test, I'll tell you, report it. I'll be explicit. If I don't, be reasonable. Okay, where I will take off points. If you report all these thousands of digits on your calculator screen, and I'll take off half a point. That doesn't make sense. Okay. You see, if your problem has 2 decimal places and 3 decimal places, and you report your answers to 15 decimal places just because your calculator shows it, okay, is that right or wrong? Yes, sir, David, it's not right. Okay, you report it to 2 or 3 decimal places. Okay, so be reasonable. Okay, be reasonable. All right, let us do some of these. Okay, one thing here for whole numbers. Okay, whole numbers, the significant figures are ambiguous. Okay, so I will not give you whole numbers on the exam. Well, this has how many sig figs? 4. But the minute I do 5,000, we can't say. Okay, so this is, it could be 4, it could be 3, it could be 2, or it could be 1. I could represent 5,000. It's a whole number, but those again, these zeros are a tricky matter. This, I can have it at 4 sig figs, making those zeros significant. I could have it at 3 sig figs, or 2 sig figs, I could say. That would be 2 sig figs. How can I make it 3 sig figs? Okay, how can I make it 1 sig fig? Okay. So this is kind of ambiguous. Okay, you have to convert it to scientific notation. Is everyone here kind of familiar with scientific notation? Okay. All right. I see some nods from our class, so okay, you just go with 2 sig figs, 3 sig figs, 1 sig figs, 4 sig figs. So you don't know. Okay, I will not ask you this on the test, but something like 4,000, 5,000, just don't know. Let's do some problems here. Bless you. All right, how many sig figs are in 478 centimeters? Good. How many sig figs in this one? Good job. This one? Yes? A little bit confident here. How about this one? Nice job. Okay, for exponents, scientific notation, you're just going to count that. Okay, so how many digits are there? 4. And this one? Okay, if I want to report this to 1 sig fig, how can I do that? Yes. How about 2 sig figs? How about 3 sig figs? And then finally 4 sig figs. I can do 10 to the power of 1, I guess. Or 7,000. So that would be ambiguous. Okay? So I will not ask you this on the exam, but I think it's my responsibility to let these guys, the other majors know this is what happens, okay, if you have a whole number like this. All right, so I think you guys did good on this, but what happens when we do computation? Let's move on. Okay, there's the addition and subtraction computation. Are there any questions or comments? Okay, the addition or subtraction for sig figs. The rule is the weakest link is the number of decimals. Okay, the number of decimal points are the weakest link. All right, so this is for addition and subtraction. This is for addition or subtraction, doing computation. We will never report everything on our calculator just because our calculator shows this. Okay? We just report what we can report. So we know this to 3 decimal places. We know this to 1 decimal place. For addition and subtraction, the weakest link is the number of decimal points. For addition and subtraction, the weakest link is the number of decimal points. So what should we report this answer? Are we going to report 90.632? We're going to report that whole thing. Okay, this is to 3 decimal places. This is to 1 decimal place. For addition and subtraction, the weakest link is the number of decimal places. So what should I report this as? To 3 or 1? Okay, we only know this number to 1 decimal place. So why do we need to report our final answer to 3 decimal places? Okay, we can only report our answer to 1 decimal place because that is the weakest link. So the answer to this is 90.6. Is everyone okay with this? 90.6. Okay, what about this one here? For addition and subtraction, the weakest link is the number of decimal places. This is to 4 decimal places. This is to 3 decimal places. Okay, are we going to report everything in our calculator? No. We're going to report all those digits. Okay. How many decimals should we report this as? 96.89. Oops, sorry. Sorry about that. So we have this to 3 decimal places. We're going to report this to 3. I'm getting 68.195, okay? Okay. The weakest link for addition and subtraction is the number of decimal places. What is the weakest link for multiplication and division? Yes, smallest number of significant figures. Good job. The weakest link for multiplication and division is the smallest number of sig figs. Okay, that's our weakest link. Smallest sig figs. All right, 4.51 times 3.6666. How many sig figs are here? 3, right? 4 and 5 and 1 are real. Yes?
Yes.
You meant 3. Okay. You got it right. Okay, we're doing multiplication and division. How many significant figures are here? 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, so what should our final answer be? To 3 sig figs or 8 sig figs? 3. That's the weakest link for multiplication and division. So 4.51 times 16.5, 366. I'm going to round at 74.6. Is that okay? 74.6. How about this one?
I have a question.
Yes, sir.
On the, what we're saying is 3 sig figs.
Yes, sir.
Why did we do that with the 1 above?
Because for addition and subtractions, you're only looking at the number of decimals. For multiplication and division, you're looking at the number of sig figs. Yeah, that's the rule. Right? Okay, good question. Noah is asking for addition or subtraction. The weakest link is the number of decimal places. For multiplication and division, what's the weakest link? The number of significant figures. So how many sig figs are in this one? And this one? Is that 0 sig? Yes, that 0 is significant. So we're going to report this to 2 significant figures because 2, we only know this to 2 sig figs. So the answer here, 2 sig figs, I'm going to go with 0.061. This has 2 sig figs. I'm rounding it. right, are you okay on this? Okay. Like I said on the exam, I'll be explicit. Reported to 2 decimal places, reported to 3 sig figs. But I do not want, I repeat this over again, I don't want you to put like 10 digits, okay? Okay, you're not going to report this to, all the digits on our calculator screen. We need a cutoff. Okay, we need a cutoff. All right, 11,254.1 plus 0.1983. What do you guys think? It's addition, right? And for addition, how many decimal, what's the weakest link? Okay, we know this to 1 decimal place. We know this to 4 decimal places. We will report our answer to how many decimal places then? 1. $11,254.3, I think, something like that. Okay, let's also try to put our units. Okay, yes, units. Okay. All right, subtraction. This has 2 decimal places. This has 3 decimal places. Our final answer should be how many decimal?
2 decimal.
Right. Good job. 2 decimal places. I'm going to go 63.2 decimal places. 63.48 liters. 63.48 liters. That's the rule for addition and subtraction. Okay, for multiplication, it's a little bit different. For division, it's a little bit different. So 8.16 times 5.1355. So we're not gonna report all those digits. I'll automatically deduct points. Okay, it's too many digits. Okay, how many should we report this to? 41.9. We'll put up meters there. 41.9 meters squared. Okay. And finally, the same thing with division. 0.0154 divided by 88.3. What do you guys think? Okay, this has how many sig fig? How many here? 3. Okay, so this is real, 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 and then 3. Right? So final answer here is okay. We wanted a 3 sig figs. I'll put this in scientific. Is that okay? Or I can do this. 0.000174. Okay, let's put our units in there. Kilogram per mil. Okay, I could also do 1.74 times 10 to the minus 4 kilograms per mil. All right, are we okay with this? Yes, good. So just beginning of how to do significant figures computation. You can get more complicated later on, but this is the very basics I want to go over. All right, accuracy versus precision. Let's go over this. In the lab, for those of you that are in the lab, we're going to measure water. Okay, so it's just water. So we're going to try our goal. Our goal is to get 10 mils of water. Distilled water. We'll measure the distilled water using a beaker. Okay. We'll measure the distilled water using a graduated cylinder. And we'll measure the distilled water using a glass pipette. Are you just going to do this one time? Oh, I measure out 10 mils, I weigh it, it's 10 grams, and the density of water is 1 gram per mil, so 10 mils, 10 grams, I got it. I'm good, I'm very good at measuring water, I'm the best. I'm going to pour out 10 mils in a graduated cylinder, I weigh it, it's 10 grams, 1 gram is equal to 1 mil for water, it's good, I'm awesome, I'm very good at measuring 10 mils. Okay, that may have been a fluke, okay? So if you like basketball, okay, you throw a free throw. I can make a free throw in basketball. If I make one, it's more likely a fluke. If I make 10, then I'm really good at free throws. Okay, same thing here. Accuracy versus precision. Okay, first of all, we got to do this many times. Okay, you got to do your reps in. So we always do replicates. What does replicates mean to you guys? What is?
Making something like twice.
Not just twice, over and over and over again. Okay, over and over again. Okay. One time it may have been a fluke, David, right? Yeah. So we got to do it multiple times. I think you're going to do it 4 times. Okay, 4 times in your lab. Right. So make sure you check that lab up before the lab today. So 4 times, 5 times, 3 times. We just don't do it once. Okay. So if we do it 4 times or 5 times and we are consistently getting 10 mils, or we're consistently hitting our target, we're consistently hitting what we want to hit, okay, we are accurate. Okay, kind of like the darts, okay, you're accurate. When you play darts at the bar, they don't give you 1, they'll give you like 4 or 5, right? Am I right? Okay, so accurate means, or accuracy means, you're hitting the target. Okay, the target for the lab, for the water lab, is 10 milliliters. I don't know what that is. Okay, we're trying to get to 10 milliliters, okay? Now, if we're reproducible, if we hit 10 mils with the beaker, I think that's the hood over there. No, is it there?
It's that way.
Somebody's saying this way, somebody's saying that way. If it's that way, I know what it is. It's the fume hood. Okay, the fume hood hit an alarm. Okay, so we'll have to tune that out. I still don't know whether it's this way or that way. This way.
I think it's throwing us off because that door's open, but I'm pretty sure it's that way.
Gerardo, can you close the door? Or David? Yeah. Close that door. Now, where's the sound coming from? All the arrows are pointing, or all the hands are pointing that way. So, I think I know what it is. That's the fume hood in the chemistry lab, which means something is off there. Okay, so are we accurate here? Yes. Okay, are we precise? Are we reproducible? Can we make 10 free throws in a row, 100 free throws in a row? Can we hit 5 darts in the target area? Can we consistently get 10 mLs? Is this accurate and precise? I would say yes. Okay, yes. I would say yes. What about this one? Are we accurate here? Okay, we are not accurate, okay?
But consistent.
But consistent, so we are precise. Very good. consistently wrong. Okay, but we are at least consistent. Hey, that counts for something, right? And what about this one? This is probably me. Not accurate, not precise. Okay, maybe drunk. Okay, if you're playing actual darts. No? Yes. Okay, so just remember, precise means how reproducible. Can we get it over and over and over and over again? So accurate means hitting your target. Precise means reproducible over and over and over again. Let's do some problems here. Okay. And then I want to lecture you guys on the periodic table, and then that's my plan for today's class. Okay, making good progress. Okay, and obviously we'll have time for review. As we finish up more and more of this material, as we go through one pass. All right, a person's average daily intake of glucose is 0.0833 pounds. What is this mass in milligrams? I'll give you this on the test, okay? So you don't have to worry about that. Okay, so you don't have to memorize any conversions from pounds to grams or so on and so forth. So 0.0833 pounds. Okay. Where am I going to put the pounds? In the denominator or numerator? I want to cancel it out, so I'm going to put it in the denominator. Okay. Times. The conversion is this. There is 1,000 milligrams. Milli means 1,000 in 1 gram. Okay. I think this is something you should know, okay, because you'll use it often. Okay, this is something I'll give. You do not have to memorize that. Okay, but this is something good to know, good to memorize. All right, I like canceling out units. Pounds, grams, grams. Yes? And what do you guys get? 0.0833 times 453.6 times 1,000. Okay, now for sig figs, okay, this has 3 sig figs. So I'm going to report this to 3 sig figs. Okay, so I'm going to put it in scientific. Oops. Oh well. I'm going to put it in scientific, so I'll make that 3.78 times 10 to the 1, 2, 3, 4. 10 to the 4. Okay. So the reason why I put it to 3 sig figs because the number in my problem has 3 sig figs, and I decided to report that to scientific to get it to 3 sig figs. Yes, no. And an average adult has, I'm going to move on, okay? Everyone fine? An average adult has 5 liters of blood. What is the volume of blood in meters cubed? Okay. Okay. I'll tell you this also. 1 centimeter cubed is equal to 1 milliliter. Okay, I'll give you this on the exam. You do not need to know that. Okay, so that's the conversion. I'll give you that. Okay, I'll give you that. All right, so we have 5.2 liters of blood, and we want it to meters cubed. Okay, how will we do that? We know that 1 liter has how many milliliters? If 1 gram is 1,000 milligrams, 1 liter is how many milliliters? Milli is 1,000. Okay, 1 mil, this is something I'll give you. 1 mil is 1 centimeter cubed. And then, anybody know meters to centimeters? 1 meter is, it's 100. Okay, 100. Okay, centi means 100. Okay, what do I need to do with this fraction? Well, I can cancel out the liters, liters, mils, mils. I can't cancel out the centimeters cubed. What's centimeters? So what do I need to do to cancel out the centimeters cubed? And not only that, get to meters cubed? Cube it. Okay, if I cube it, I'll get my units in meters cubed, right? Very good. So what should I do with this 100? Cube it. Times it by 3, meaning 100 times 100 times 100. Okay. So that's what we need to do in our calculator. Our units are going to be liters, liters, mils, mils, centimeter cubed, and then I'm left with meters cubed. Okay, but cube that 100. I think a couple of years ago, even last semester, you forget to cube the 100. Okay, you forget to cube the 100. All right, 5.2 times 1,000 is 5,200. Okay, divided by 100 cubed. Divided by 100 cubed. This is what you guys are getting. 0.0052 meters cubed. So this is 2 sig fig, so I'll just do it to 2 sig fig. 0.0052. Put our units. 0.0052 meters cubed. Okay, put your units in, you guys, all right? How about this one here? Okay, a couple more. The density of the liquid at its boiling point is 0.808 grams per centimeter cubed. Remember, density is mass over volume. Convert the density to units of kilograms per meter cubed. Okay, kilograms per meter cubed. 0.808 grams per centimeter cubed. Okay, we want it to kilograms over meters cubed. Okay, so we need kilograms up on top. So 1 kilogram is how many grams? 1,000 grams. Yes? Okay, 1 kilogram is 1,000 grams. Okay, it's probably a good thing to memorize or keep this in the back of your head. How do I get to meters cubed at the bottom? And what should I do with this one here? Yes, cube it. Okay. All right, the grams cancel. Centimeter cube cancels with the centimeter cube. What should I do with this 100? Cube it. What are my final units? Kilograms, meters cubed. See that? Kilograms, meters cubed. right, so what's 0.808 times 100 cubed? Okay, make sure you know how to do this on your calculator. Divided by 1,000. 808. Yeah, it's fine. 808. All right, so we went from grams to centimeter cubed to kilograms per meter cubed. Okay, we did the switch, the conversion. Right, I didn't teach you this, but we'll go ahead and do it anyways. Okay, the molecular weight of HCl, hydrochloric acid, is 36.01 grams per mole. How many grams are there in 0.25 moles of HCl? So I did not teach you mole, other than what is the mole? Okay, a mole, page 4 of our notes, is the SI unit, the base unit, for the amount of substance. Amount of substance. It's not a mass. It's not a mass. Okay, so 10 grams is different than 10 moles. 10 kilograms is different than 10 moles. Okay, so we got a unit here that we really haven't really taught you anything about it. I didn't teach you anything about the moles. But we'll go ahead and do this problem. Okay, so how many grams are in 0.25 moles? So moles is this amount. I have this much amount. And this much amount is 0.25 moles of HCl. Okay, how will I get it to grams? Okay, how many grams are in 1 mole of HCl? So I didn't teach you anything about the mole, but we just did our conversion. Moles cancel. And this should be about 9. 9.0. Let's see here. We got 2 SF here, 2 sig figs, 4 sig figs. I'll just report this to 2 sig figs. 9.0 grams of HCl. Okay, this is our answer. 9.0 grams of HCl. Okay. So I want to show you something very interesting here. Okay, just hear me out. If you have your periodic table, if you don't, that's okay. I'll give you some. Or you can get it later after class. Okay, HCl, what is it composed of? Hydrogen, and what's Cl? Chlorine. So if you look at hydrogen, you see that bottom number? Okay, it's about 1.01, and I'm going to call it grams per mole. Okay, you see that Cl here? You see this bottom number? 35.45 grams per mole. Okay, for HCl, which is composed of H and Cl. If I add that up, what do I get? And 36.01. Okay, so this is the molecular weight. I'm a little bit off because I did this on top of my head. I don't have the exact numbers memorized. But yes, this is the molecular weight. Okay, this is the molecular weight. So the molecular weight of HCl is 36.46. Because I did this on top of my head, I wrote 36.01. Okay, but this is the idea. Okay, the molecular weight of a compound, you add these numbers. You add the bottom numbers. Any biology majors? I already surveyed the engineering majors. Any biology majors? Okay, all you biology people. Glucose is C6H12O6. Okay, you may see that as glucose, or may know that as glucose molecule, main sugar in the body. What's the molecular weight of glucose? With its 6 carbons, 12 hydrogens, and 6 oxygens. Okay, how much is the carbon? 12.01, but how many carbons are there? so we got to multiply it by 6. Hydrogen, I have hydrogen memorized as 1.01. Okay, so you can do you can do that whole number, but when you're in a rush and in a hurry and you're doing these problems, to me hydrogen is 1.01. Okay, so we'll just go at 1.01 times 12. Very good. And then oxygen, how much is oxygen? Okay, you can go 15.9994. It's perfectly fine. But if I don't have my periodic table, or if I'm in a hurry, or if I'm in the middle of an exam, okay, it's okay. It's okay to go with 16.01. It's okay. So this would be for carbon. This would be for hydrogen. And this would be for oxygen. So what is the molecular weight of glucose? 1 mole of glucose contains how many grams of glucose? Okay, 6 times 12.01 plus 12 times 1.01 plus 6 times 16.01. Okay, more or less, we're looking at about 180.24 grams of glucose. So if I weighed out 180, if I go in a scale and weigh out 180 grams of glucose, okay, how much glucose, and I give it to you, how much glucose did I give you? 1 mole. Okay, 1 mole. Okay, so if I give you 180.24 grams, David and all you guys, I gave you 1 mole. Okay, they're not the same. Okay, but 1 mole is this many grams. All right. Can we do one more? How about water? What do you think about water? 1 mole of water contains how many grams of water? 1 mole of water contains how many grams of water? What's hydrogen? They got here 1.00794, but that's okay. We'll just go with 1.01. Depends how many digits you want to report, how accurate you want to be. Times 2, good. And then oxygen, 15.994. I'm just going to round it to 16.01. You can do 15.99. Our answers will be pretty much the same. Okay, 16.01 grams are in 1 mole of oxygen. So for H2O, this will be hydrogen, and this would be oxygen. Why did we multiply it by 2? In water, there's 2 hydrogens that have come together. So 1 mole of water contains how many grams of water? 18.03 grams. Okay. So this is how it works. Okay, that bottom number gives you information about the molecular weight. Okay, it's the molecular weight. It's how much in grams 1 mole carries. It is how much in grams. So if I were to go to the lab and weigh out 18 grams of water, put it on a scale and weigh out 18.03 grams of water and give it to you, how many moles of water did I give you? How many? 1 mole, right? If I gave you 36.06 grams of water, how many moles did I give you? 2. If I give you 9 point, I don't know. Okay, if I gave you 9.02 or 9.015 grams of water, how much water did I give you? Half a mole, 0.5 moles of water. Okay, you guys see this? Okay, moles and grams. Okay, you have to, convert them. Grams to moles, moles to grams. All right, our last problem. So I didn't teach you the mole, but I kind of did teach you a little bit of the mole now. Okay. All right, our last problem. We'll take a little couple minutes break, and then I will lecture on the periodic table. It's good because you can use whatever notes you take on your periodic table for the test. All right, the concentration of a substance is known as molarity. I didn't teach you this. I'll teach this to you in chapter 4, but that's fine. It has the units of M. The big M also means moles over liter. Okay, so we have moles, which is the amount of substance. Okay, remember moles is the amount of substance. Okay, moles is the amount of substance, not the same as grams. And then we have volume over liters. Okay, so volume is in liters. So this is a concentration. This is called molarity. Okay, so we'll teach this more specifically in chapter 4. I haven't taught you this, but we can still do this problem. How many moles are in 25 milliliters of 0.25 molar HCl? 0.25 molar. So what does 0.25 molar mean? Okay, it means 0.25 moles over a liter. What does 1 molar mean? 1 mole over a liter. Okay, what does 0.636 molar mean of HCl or whatever chemical? What does that mean? Mole over liter. Okay. Are we okay with this? This is a concentration. Let me ask you this. If I were to add water to this 0.25 molar, big M, molar, molarity, HCl, what would its concentration be? Would it be higher than 0.25 molar or lower than 0.25 molar? I add water to something. Lower. Very good. This is dilution. Okay? If I add water, I'm diluting it. Just like that, if I add water, I dilute the concentration. Right? If I add water, I dilute the concentration. All right, let's solve this problem here. How many moles are in 25 ml? So 25 ml. Let's convert that to liters. Okay, what did we say 0.25 molar HCl was? Per liter. Okay, the same thing. And then 1 mole of HCl contains how many grams of HCl? Okay, now we can give a little bit better, a little bit more accurate molecular weight. How much is hydrogen? We'll add some digits here. 1.01 grams per mole. How much is Cl? We'll go with 35.45. Okay, a little bit better than the last problem. So 35.46 grams are in 1 mole. So 1 mole of HCl contains 35.46 grams. Okay? We just add those numbers up. Okay? Okay, this is the molecular weight for hydrogen. This is it for chlorine, so 35.6 grams of HCl per 1 mole, 5.46 grams per 1 mole of HCl. We put that here. So the mils cancel, the liters cancel, the moles cancel. And what do we get? 25 times 0.25 times 35.46 divided by 1,000. Okay, what do you guys get? 0.22 grams. This is 2 sig figs. I think that's good. Okay. We'll do 0.22 grams. Okay, so there's 0.22 grams in 25 mils of a bottle of HCl, which has what concentration? 0.25 molar. Okay? 0.25 molar. All right, we'll talk a lot about this in chapter 4, but if you understand this now, and it's really nothing new, okay, I just want you to get the idea of canceling out units. Okay, this is just canceling out our units. All right, how many grams are in 25 mLs of 0.25 molar HCl? Oh, we answered it, so this is part C. Okay, 0.22 grams. Okay, how many moles are there? Okay, how many moles? We'll just stop right here. Okay, 25 times 0.25 divided by 1,000. 0.00625 moles. Okay, I'll do 0.0063 moles. Okay, so that's the answer for part B. So if we want the number of moles, we'll stop here. If we want the number of grams, what do we need to do? Okay, use the molecular weight. Okay, if we want the number of moles, we'll stop here because 0.25 moles of HCl, 0.25 molar HCl is really what? Moles over a liter. But if you want grams, 1 mole of HCl is how many grams? Add those numbers up. Okay, add those bottom numbers up. Okay, add this number. Add this number. So 1 mole of HCl contains how many grams? Add the H, add the Cl. 1 mole of glucose contains how many grams? Add the carbons times 6, add the hydrogens times 12, add the oxygens by 6. That's what you get. Okay, 1 mole of water, add the hydrogens times 2, add the oxygen. Okay, add them up. This is what you get. Okay. So this is your molecular weight. Okay, 1 mole is that many grams. 1 mole is that many grams. Okay. So let's see the time here. I got, I think, 15 more minutes. So let me just take these 15 minutes to talk a little bit about the periodic table. Okay. So I have a stack here, but let me just go over some things, just very briefly, maybe 10 minutes or so. Okay. I don't know if I printed out enough for everyone, but you can go ahead and just pass it out. So you can bring your own periodic table to the exam, and if I don't have any, you can have this copy. Okay? I'll scan it and put it on Canvas. So whatever periodic table you use, whatever you get off the internet, you can use that. This is one I just found, so I'm going to use this. So, guys, we'll just hand out those periodic tables. All right, so we finished chapter 1. So I do not know when I made the homework due for homework 1, but turn that in. I forget the date I put on Canvas. So do those problems, check your answers, watch the video if that helps, and turn that in. I'll give you 10 points. So chapter 1 is in the books. That's a wrap. Before we go to chapter 2, let's just talk a little bit about this periodic table. First of all, okay, you can bring this to the test, okay? You do not memorize such a thing, okay? You don't memorize such a thing. I was reading a book on the periodic table. Do I have it? Probably not. Okay, there's a good library book that I got on the periodic table talking about how Mendeleev made the periodic table, and he had a big ego, and people were angry, and they had fights over where to place the elements, and he put a lot of blanks in there. So it's a very interesting history. We're talking about 1800s, 1900s or so. So this is and he even left blanks. Okay. So this is our periodic table. Again, like I said before, you can use whatever one that you find interesting or find more convenient. This is kind of like a guide. Okay, this should tell you something. The idea is that you look at it and you should be able to pick up something very, very quick. Okay, very quick. So let's, hopefully I can teach you that. Let's focus first here. We can do any box, but I'll focus on the iron. Okay. So what is the symbol for iron? Fe. Okay. The symbol for iron is Fe. Okay, let's first talk about that number 26. Okay, this 26 is called the atomic number. Okay, it is the number of protons in the atom. Remember protons? Okay, where are the protons? Are they in the center? Or are they outside? Okay, they're in the center. The electrons are on the outside doing stuff. Okay, but this atomic number 26 is the number of protons in the atom. Okay, and this atomic number is invariant. Okay, this atomic number is invariant. Okay, what does invariant mean to you? It does not change. Very good. Excellent. It does not change. Okay? It does not change. Anybody here have a favorite athlete? Who's your favorite athlete, Darnell? Okay, what is his number? 23. 23 is his number. What is, I don't know, who is 16? I don't know. Okay. Right. So LeBron is 23. Who else? Anybody else? Messi. I think he's a soccer, right? What's his number? 10. Anybody else? Go ahead. Alex Morgan. What's her number in soccer? 13. Okay. Is it 14? No. 14 is a different player. Probably we don't know her that well. Is LeBron 16? No, that is... I don't know who plays for the Lakers now. Okay. Magic? No, not Magic Johnson. So this atomic number does not change. Okay, it does not change. Okay, if you change the atomic number, what will you get? You don't get LeBron at 23 or Alex Morgan at 13 or Messi at 10. Okay, what will you get? Someone else. What happens if you change the atomic number here? You get a different element. You get a different element. Okay, so you change the atomic number, you change the number of protons, you get a different element. So change this, you change the element itself. So that's what we mean by invariant. Okay, so how many protons are in copper? Okay, what happens if it's 30? Will copper have 30 protons? No. If I change to 30 protons, I don't have copper anymore. I have zinc. So that atomic number is like your roster number on an athlete. Okay, it does not change. We associate 26 protons with iron. Okay. So the next thing I want to tell you is this bottom number. Okay, this bottom number has three meanings. 55.845. I'll give you those three meanings and then we'll end class. Okay, the first one we already know. The first one is the mass, well, Okay, this first one is the mass in grams of 1 mole of the atom. Okay, mass in grams of 1 mole of the atom. 1 mole, grams. Okay, 1 mole of the atom. So 1 mole of iron contains how many grams? Mass in grams of 1 mole of the atom. 1 mole of iron contains how many grams of iron? If I were to weigh out 55.845 grams of iron, how much did I give you? I gave you 1 mole. So that's one definition. Okay, the second definition is what we're going to call the mass number. Okay, which is the number of protons and neutrons in the atom. Okay, so this is definition 2, the mass number. Okay, this is the sum or the number of protons and neutrons in the atom. Okay, so what's the sum of protons and neutrons in iron? 55.845. And then the last one is, last definition is the mass of the atom, but the mass is going to be in units of AMU, atomic mass units. Okay? Okay, this AMU stands for atomic mass units. So, 3 definitions for that bottom number. Okay, of this 1 mole is this many grams is going to be important in this class later on. Okay. All right, mass of the atom in AMU. So how much does iron weigh in AMUs? 55.845. Okay, that's how much it weighs in AMUs, atomic mass units. Okay, how many protons and neutrons are in iron? I think I have 4 minutes. Oh, it's 10:45, right? How many protons and neutrons are in the iron atom? 55.845. Okay.
The 26 you said was the number.
Protons. Yes, 26 is the number of protons. But what is the number of protons and neutrons together? 55.845. Okay. 1 mole of iron contains how many grams of iron? 55.845. How much does iron weigh in terms of atomic mass units? 55.845. So I think I will end class now. It's a good time. As any